Ever wondered why p-value holds such significance in the realm of statistical analysis? Well, let's unravel this mystery together. Picture the p-value as a little detective in the bustling city of data. Its job is to help us decide whether our findings are significant or if they're just a result of randomness, a mere fluke. In essence, it's a probability that measures the strength of evidence against a null hypothesis, the initial claim we make about a population. The smaller the p-value, the stronger the evidence to reject the null hypothesis. This is why it's a hot topic for many, including data analysts. It's a tool they use to make informed decisions, to distinguish signal from noise in a world bursting with data. So whether you're a seasoned analyst or just a curious mind, the importance of understanding p-value should not be underestimated. By the end of this discussion, you will grasp the significance of p-value, even if statistics isn't your cup of tea. So, what exactly is this p-value we're talking about? Well, let's demystify it. Imagine you're flipping a coin, heads or tails, right? But what if you flipped that coin 100 times and it landed on heads 85 times? Something seems off, doesn't it? This is where p-value steps in. It's a tool used in statistics to help us decide if what we're observing is due to chance or if there's something else at play. In our coin example, a low p-value would suggest that getting 85 heads out of 100 flips is highly unlikely to be just by chance. But remember, the p-value isn't telling us about the actual number of heads or tails we got. It's telling us about the probability of getting that many heads or tails. It's a measure of surprise, a way of saying, hey, this result is kind of unusual. Now let's think of a real-world example. Suppose we're testing a new drug. We give the drug to a group of patients and a placebo to another group. At the end of the trial, we notice that the patients who took the actual drug show significantly more improvement than those who took the placebo. But is this difference due to the drug, or could it just be a random occurrence? This is where we calculate the p-value. If the p-value is low, say less than 5%, we'd say that it's unlikely the difference we observed is due to chance. The drug probably does have an effect. But if the p-value is high, say more than 5%, it's more likely that the difference we observed could just be due to chance. The drug might not be as effective as we thought. So the p-value doesn't tell us if the drug is effective or not. It tells us the likelihood of observing a difference as big as the one we saw if the drug had no effect. In essence, p-value is the probability of obtaining results as extreme as the observed results. Despite its simplicity, p-value is often misconstrued. Let's clear the air. The p-value, a cornerstone of statistical analysis, is often met with misconceptions, muddying its true meaning and purpose. One of the most common misunderstandings is that the p-value speaks to the importance or size of the effect, but in reality, it doesn't. The p-value doesn't tell us if an effect is big or small, important or trivial. It doesn't measure the effect size at all. Instead, it tells us about the probability of observing our data, given that a null hypothesis is true. In other words, if we assume that there's no effect, no difference, no relationship, that's our null hypothesis. Then the p-value gives us the likelihood of stumbling upon the data we have. A small p-value suggests that our observed data is unlikely under the null hypothesis, leading us to question its validity. But it doesn't tell us anything about the magnitude of the effect we're investigating. Another misconception is that the p-value is a reflection of our sample size. This is incorrect. While it's true that with larger samples, we're more likely to find statistically significant effects, the p-value itself is not a measure of sample size. Again, it's about the probability of our data given the null hypothesis. It's not telling us how many people we surveyed or how many experiments we ran. It's telling us how likely or unlikely our data is, assuming the null hypothesis is true. Finally, a common pitfall is to interpret the p-value as the probability of the null hypothesis being true. This is a fundamental misunderstanding. The p-value assumes the null hypothesis is true to calculate the probability of the observed data. It doesn't provide the probability of the null hypothesis itself. So, let's dispel the myths and misconceptions. The p-value is not about the size or importance of the effect, it's not about the sample size, and it's not the probability of the null hypothesis being true. Remember, p-value is not a measure of effect size or sample size, it's all about probability. Now that we've demystified p-value, let's explore its practical significance. In the real world, p-value is a vital tool in many fields, from medical research to market analysis. Its primary role is in hypothesis testing, a cornerstone of statistical analysis. In essence, the p-value aids us in making decisions based on data. But how does this work? Picture a pharmaceutical company testing a new drug. They start with a null hypothesis, the assumption that the drug has no effect. They then collect data from clinical trials, and the p-value helps them decide if their results are significant enough to reject this null hypothesis. The lower the p-value, the stronger the evidence against the null hypothesis. If the p-value is less than the predetermined significance level, often 5%, they can confidently say that the drug has an effect. Similarly, in market analysis, a business might want to know if a new advertising campaign has increased sales. The null hypothesis would be that the campaign has made no difference. By collecting sales data and calculating the p-value, the decision to continue or halt the campaign can be made with statistical confidence. So, in these and countless other scenarios, the p-value serves as a compass, guiding us through the sea of data towards informed decisions. We're not left to rely on guesswork or gut feelings. Instead, we have a scientifically sound method to make choices rooted in data. So, p-value is like a tool that helps us make informed decisions based on data. Before we wrap up, let's summarize the key points about p-value. Think of it as a measure, one that tells us how unusual our data is, assuming a certain hypothesis is true. Beware of common misconceptions, like confusing it with the probability of the hypothesis being true. And remember, it's not just about getting a small p-value, but about understanding its practical significance in context. So, next time you come across p-value in a statistical analysis, remember, it's not as complex as it sounds.